Hello everyone and welcome to one of the session for the thermodynamics subject. This is the last session for chapter 2 energy system of this subject. So today I start to show you two examples related to the mechanical uh, energy conversion, the discussion which we have started in previous session about the efficiency of mechanical and electrical devices. We discussed about the turbine and also the pumps and also the combination of this pump and motor and also turbine generator. And I introduced you the different relationship and the questions to calculate these motor efficiency, generator efficiency, or the pump motor efficiency or turbine generator efficiency, which is mainly conversion from mechanical to electrical energy or vice versa. So we have one example here, which is for power generation from a hydroelectric plant. And electric power is to be generated by installing a hydraulic turbine generator at a site 70 meters below the free surface of large water reservoir that can supply water at a rate of 1,500 kilogram per second steadily. This generator is illustrated, and this plant is illustrated in figure 260. You can see here the turbine is here, the elevation or the height, the difference between the elevation of the reference and also the uh, generator. You can see here the turbine. You can see here is 70 meter, which is mentioned, and also the flow rate of the water from this reservoir to the turbine is also mentioned, which is 1,500 kilogram per second steadily. This is important steadily. It means the flow rate is constant and it doesn't change with time. If the mechanical power output of turbine is 800 kilowatt and electric power generation is 750 kilowatt, we need to determine the turbine efficiency and the combined turbine generator efficiency of this plant. We can actually neglect the losses in the pipe. This can be one of our assumptions. So what we need to calculate here is to calculate efficiency for combined turbine generator and also for turbine, uh, the efficiency also for the turbine. What we have is the information which we have here, this uh, height which we have, and also the flow rate or m dot of the water through the turbine. We have the electric power which is generated and also the mechanical power output of turbine. We have all of this information. First, we should choose a reference for this plant. If you notice, just simply the potential energy which we have for water in this aid or for the reference will be converted at the turbine to kinetic energy on the blade of the turbine. So we take the free surface of water in this reservoir to be zero point 0.1 and the turbine exit to be 0.2. 0.1 the surface of the water and 0.2 exit of the turbine. We also take the turbine exit as the reference level, Z2 equal to 0. So that the potential energies at 1 and 2 are PE1 equal to potential energy at the point 1. This one is equal to the GZ1. Z1 here is 20 meters. And in point 2, the potential energy is 0 because we don't have any elevation. So potential energy here, because of the z is equal to 0 for this point, and z2 is 0, z1 is 70 meter actually. So the potential energy for point 2 is 0. The flow energy, or P divided by rho at both points, is 0, since both point 1 and 2 are open to the atmosphere. This P1 and P2, the pressure at both this point is open to the atmosphere, so the flow energy is 0. Further, the kinetic energy at both points is 0 as well, because here the water doesn't have any motion, and also here we can imagine there isn't any motion with the water in this point as well, since the water at point 1 is essentially motionless, and the kinetic energy of water turbine is assumed to be negligible. Then the potential energy of water at point 1 is PE1, or potential energy at point 1 equal to GZ1. G, or gravitational acceleration, we know that at the surface of Earth is 9.81 meter per squared second, times the Z is 20 meters. By using this unity conversion, we can convert this, and finally we will have this much for the potential energy at point 1. So potential energy of water at point 1 is 0.687 kilojoule per kilogram. So we have calculated the potential energy for the water at this point. Then this potential energy is converted to the kinematic energy at the blade of the turbine. Then the rate at which the mechanical energy of water is supplied to the turbine becomes delta E dot mechanical flow is equal to m dot E mechanical in minus E mechanical out. How we know this? Because of a previous slide, we have calculated this. Our, we have already discussed about this delta E that mechanical uh, uh, fluid, the change in the mechanical power of the fluid is equal to change in the mechanical input and output in the turbine, and also the mass flow rate of the fluid which is supplied to that turbine. So simply we can write here that we know that how much is it, 1500 kilogram per second, and also E mechanical in is equal to the potential energy. The whole potential energy here will be converted to the kinetic energy, because here we don't have any potential energy, and whole potential energy according to the first law of thermodynamics or conservation of energy, potential energy in this point is converted to the kinetic energy. So m dot times E mechanical in minus E mechanical out. E mechanical out is 0, motionless fluid after turbine, and before turbine is equal to this much P, or potential energy at point 1. So finally, the mm, mechanical power difference for the fluid before and after turbine will be m dot potential energy at a point 1, and we have m dot, we have potential energy as well. Then by multiplication of these two values, we will have the mechanical energy rate difference for the fluid before and after turbine, or mechanical energy of water which is supplied to the turbine. Then the combined turbine generator and the turbine efficiency are determined from their definition to be, this equation. If we just go back, efficiency of turbine generator, we have this equation for that W dot electric out or electrical power divided by turbine power or the mechanical power uh, differences of the fluid before and in the turbine actually. We have calculated this value delta in that mechanical for the fluid. This term means how much is the energy of the working fluid before and after turbine. So before turbine is equal to this because we have this much of energy, potential energy here, and after that this will be zero because it is motionless, and also it's it is in the reference, so potential energy is zero and also kinetic energy is zero. So we have this much energy on the turbine which comes from the fluid motion to the turbine. So by substitution, this value 1031 kilowatt, and also W dot electric out or electrical power output of the turbine or generator. We have that. It is given, which is 750 kilowatt, which is the electric power generation of the generator. So the turbine generator efficiency for this plant is almost 72.7%. To calculate the turbine efficiency, we need to uh, use this equation, electrical power generation divided by mechanical power of the fluid. We have the electrical power, mm, which is here it is given the mechanical power output of the turbine is 800 kilowatt. Actually this should be mechanical for turbine. So mechanical power output of the turbine is 800 kilowatt divided by mechanical power of the fluid. How we know this? Because we have already calculated this value of mechanical. This is this one actually, uh, which this is this one we have already calculated because this that mechanical fluid is equal to this one, which was then 1031 kilowatt. So by mm, calculation of this division, we will have the turbine efficiency, which is 77.6%. So you can see here how we can use this equation, which I have introduced to you, to uh, calculate the efficiency of turbine or turbine generator, which we have here. All of the fluid energy, which is due to its potential energy, and the height difference or elevation difference of the water. Imagine this is a dam, then the water it is reserved here behind the dam, then this water will go to the turbine by this by a pipe or something like that. Then the potential energy will convert it to the kinematic energy and goes to the turbine. We can calculate the efficiency of the turbine and generator, and we can produce or generate electricity by using of the this plant, which is a dam actually. The other example is about the cost saving associated with high efficiency motors. Here we will see how we can, how by calculation of the efficiency of a motor, we can save money or even energy for application of a motor or something like a motor. Here we have a 60 HP electric motor. It means this motor delivers 60 HP of shaft power at full load, and it has an efficiency of 89%. So then we are going to change this motor with one another motor, which we call that high efficiency motor, which its efficiency is 93.2%. You can compare these two. Almost 4.2% is the efficiency of the high efficiency motor is higher than the standard one. The motor operates 3,500 hours a year at full load. So this motor needs to be in operation this much of hours per year in full load. Taking the unit cost of electricity to be $0.08 dollar per kilowatt hour, we need to determine the amount of energy and money saved as a result of installing the high efficiency motor instead of the standard motor. So we have this motor. This is the standard motor. We know how much is its efficiency, and uh, this motor should be used is going to be used 3,500 hours per year, and we know also how much is the cost of the power for this motor. Then we are going to change this motor with this higher this motor with higher efficiency. Then we will see how much will be the uh, difference between the energy or cost for energy for these the other motors. Also, we need to determine the simple payback period if the purchase prices of standard and high efficiency motors are $4,520 and $5,160 respectively. So we have also the initial cost for the both of these two motors. For sure, the motor with higher efficiency is more expensive compared to the standard motor, but we should see this difference of the money uh, can be compensated by the saving of energy because of the higher efficiency of the high efficiency motor. Let's see. First of all, we should notice that the load factor of motor remains constant at 1 or full load when operating. It is mentioned according to the question instruction that these 3,500 hours per year should be at full load. Full load means it will deliver 60 HP, the 60 HP power. This motor will deliver 60 HP power uh, at this load. Then the electric power drawn by each motor and their differences can be expressed like this. Electric power for the standard motor can be calculated like this, which we can, if you remember about the efficiency of the motor is like this. W dot electric divided by W dot shaft for a motor. But here, because we have the efficiency and also we have the W dot of shaft, then we need to calculate W dot electric in, which is required for this motor, which is W dot shaft divided by W dot or efficiency, motor efficiency of the standard motor. So this W dot of the shaft is rated power. If you remember, the mechanical power of the shaft can be calculated like this: the rated power times load factor of that motor, the power, rated power times load factor, which is load factor is 1, and rated power we have here for this is 60 divided by its efficiency, the efficiency for a standard one. Same equation can be written for the efficient motor, the electrical power which is required for this motor to have that 60 HP. Again, we can calculate that W dot shaft or shaft power divided by the efficiency of the motor, which is W dot shaft is rated power times load factor of the uh, motor, which is for effective high efficiency motor. The power which is saved by substitution of a standard motor by the efficient one is equal to differences between these two. So power which is saved is equal to W dot electric, which is required for the standard one, minus W dot electric or electrical power, which is required for efficient motor. If we do this subtraction, the it will be like this: rated power times load factor times 1 divided by efficiency of the standard motor minus 1 divided by efficiency of more efficient motor. So we have this equation to calculate the power which is saved by substitution of standard motor with a high efficient motor. Is eta S is the efficiency of a standard motor, eta EFF is the efficiency of the motor of the comparable high efficiency motor. Then the annual energy and cost saving associated with the installation of high efficiency motor become, now the energy saving is power saving times operating hour. The power saving, we have this equation for that. The power which is saved by substitution of the motor, power saving times operating hours. In other words, in each hour, how much power is saved. Rated by, we have this equation for power saving and operating hours. How much is it? The operating hour is 3,500 hour per year. By substitution of all of these parameters, rated power is 60 HP, operating hour is 3,500 hour per year, and the also we have the efficiency for both of the motors, and also this one, this is the unity conversion. Each HP is 0.7457 or almost 75 kilowatt. So this is unity conversion to convert HP to the kilowatt, because finally we need to calculate the energy which is saved in terms of kilowatt hour per year. So the cost which is saved during 1 year, cost saving is energy which is saved times unit cost of energy. The energy which is saved is 7,929 kilowatt per year, and we know from the instruction of the question each kilowatt hour costs $0.08. So by this multiplication, finally we will have the cost which is saved per year, which is $634 per year. This is the cost which is saved due to the substitution of the standard motor with the more efficient motor. And also the excess initial cost, we are going to see, this is if we substitute the motor in first year, we will save this much of money. Then, but we have already paid extra money for this more efficient motor. So first, let's see how much we extra or we have paid for this more efficient motor. Excess initial cost is purchase price difference or differential. So this is negative $5,160 for the more efficient motor and $4,520 for the standard motor. The differences between the price of these two motors will be 640. So we can simply we can calculate after how many times or how many years these differences in the initial price will be will be covered by the saving of energy for the motor. Simple payback period can be calculated like this: excess initial cost divided by annual cost saving. The excess initial cost is $640 divided by $634 per year, which is the annual cost saving by substitution of the motor. Finally, we can see here after 1.01 year, the extra price which we have paid for the more efficient motor will be paid back by saving of the energy. And generally, these electric motors, doesn't need maintenance for years. So we can see just in first year, the initial higher price which we have paid for this efficient motor will be paid back, and after that this saving of the energy will save totally the money of our money to pay for the energy to run this motor. So it is reasonable to substitute this standard motor with more expensive motor but with higher efficiency. Okay, the next topic is about the in next few slides. We will see how energy is or energy conversion, energy consumption can be effective on the environment. The conversion of energy from one form to other form often affect the environment and the air we breathe in many ways. And thus the study of the energy is not complete without considering its impact on the environment. As you can see these days, we have many challenges about the global warming, the air pollution. All of these, is due to the uh, conversion of the energy from one form to the other. We have combustion, which we are going to convert chemical energy or energy in the fuel to the mechanical energy. During this conversion, different pollution or different emissions will be produced, and they are effective on the environment. So to have a better understanding about the energy conversion, we need to know about its effect on the environment as well. This energy conversion has this side effect, as I told you: smoke, acid rain, and global warming. This environmental pollution, that is important? Because it is, it is a threat for vegetation, for wildlife, for human health, even for human health, which is the main concern nowadays for society. This is just two examples: the factory and also the car, which they use fossil fuels. The conversion of fossil fuel to the mechanical energy will produce this type of the emissions or gases like NOx, or like carbon monoxide or hydrocarbon, which are uh, harmful and dangerous for these three different categories. The first categories of these pollutants are the ozone and the smoke. Smoke is made up mostly of ground level ozone or O3, but it also contains numerous other chemicals, including carbon monoxide, particulate matter such as soot and dust. and also volatile organic compound or VOC such as benzene, butane, and other hydrocarbons. As you can see, all of these materials are nowadays are categorized as emission for environment. Hydrocarbon and nitrogen oxides react in the presence of sunlight and hot, calm days and to form ground level ozone. So you can see these two type of gases also can be converted to the ozone, which is uh, harmful for human. Ozone irritate eyes. It damages the air sacs in lungs where oxygen and carbon dioxide are exchanged, causing eventual hardening of the soft and spongy tissues. So you can see it is effective on the breathing system of the human. It is also causes shortness of breath, wheezing, fatigue, headache, and nausea. And also, you can see different problems come from these pollutant or these emissions. The other more harmful mm, gas is carbon monoxide, which is colorless, odorless, and it is poisonous gas. It is mostly emitted by motor vehicle. One of the most important sources of this emission are vehicle, which use internal combustion engine and produce these gases. And also about the particulate matter and dust and soot, which may come from the internal combustion engine in the vehicles and also from the different type of plants and also industrial facilities, which can cause irritate and also uh, irritate of the eyes and also the lungs. And the other problem with the conversion of the energy, or mainly the problem is with combustion. Where we have combustion, we will have production of these gases. The other problem is for sulfur dioxide. This gas also is a pollutant. It will go to the uh, sky and in the presence of the sunlight, it will react with the water and it will cause acid rain. This acid rain, it is it can cause many problems like mm, problem for the I don't know for the exactly for uh, example for now, but it is effective on the uh, different vegetation, humans, and you may hear about that in the crowded cities. It is not a good idea to be to walking to walk during rainy days. Exactly because of this problem, because the rain droplets are full of this sulfur dioxide or acid, which is harmful for human and also for even building, even for the uh, other infrastructure. So this is one of the other problem with the this emission, sulfur dioxide. And also the other gas which is effective on the environment is carbon dioxide. Carbon dioxide is one of the most important gases which is effective on the global warming. You may heard about this problem, global warming, that the temperature of the earth is increasing, and this increase in the temperature of the Earth's surface is causing some problem like melting of the ice in the poles, south poles or north, and also it caused the climate change, the changes which we have in the weather in different areas, which cause flooding in some areas and drought in some other areas. All of these come from this global warming problem and also climate changing, which come from this global warming. The gas which is responsible for this is carbon dioxide. This carbon dioxide is in the it is generally one of the component in the air, but by combustion, which is a chemical reaction, we are producing this carbon dioxide more and more. So this carbon dioxide will be higher in the atmosphere. Higher amount of this carbon dioxide is will play a role like a blanket, and as you can see here, it will make a cloud of the different clouds of the CO2, and it will prevent of the going out of the energy of the sun. After this energy of the sun will reach the earth, and some part of that will goes out of the atmosphere of the earth. But due to this carbon dioxide and its effect, it will act like a blanket and keep the earth warm at night by blocking the heat radiated from the earth. These results global warming. So the CO2 can cause global warming, and coal, oil, and natural gas consumption, which should be, the consumption of this kind of fuel should be in a combustion reaction. So this reaction will produce CO2, which is a reason for global warming. And you can see here some of the reports related to this global warming. It is mentioned that in the current century, about 0.5%, 0.5 degrees Celsius, the temperature of the Earth is increased, and it will increase more in next 100 years, about 2 degrees Celsius. This increase will cause several changes in the weather pattern, and as I told you, it will cause some problem like flood, and also drought in some areas, which is dangerous for the uh, human life and also for the environment. What we can do to prevent these problems? What the first option is, uh, we can just ignore these all of these type of the fuel like fossil fuels, and we can use the renewable energy, such as the wind energy you can see here, or solar energy. But this option maybe in future can be the uh, can support or cover all of the energy requirement by human beings. But uh, nowadays, about 90% of the energy which we use in daily life come from the fossil fuels, because the energy content of the fossil fuels and also combustion is much higher than this type of energy. So what we can do is to make and build more efficient equipment, and also we can manage energy consumption to reduce the consumption of energy. Then we can also prevent this generation of these pollutants and emission, and we can prevent this global warming and climate changing and so on. So we have these two options, and the scientists are working on both of them to make more efficient equipment to use these fossil fuels, and also to introduce more reliable, renewable energy resources to have cleaner air and uh, also a cleaner environment. So here we have an example to see how we can mm, prevent air pollution by substitution of by using one of the renewable energy resources, which is geothermal heating. Geothermal means the temperature which is in the depth of the earth, and we can reach that energy which will come from the core of the earth, and it can be used for production of the we can convert that energy or thermal energy to other form of the energy. So in this example we have a geothermal power plant, and it is generating electricity using geothermal water, which is extracted as 180 degrees Celsius. You know, this water in 180 degrees Celsius is a steam, so this steam can be used for a turbine to run the turbine, and the shaft power of the that turbine can be converted by a generator to the electricity. So this geothermal will produce electricity by using the temperature of the earth to the by converting that to the electricity. So this is the temperature of that plant, and re-injected back to the ground at 85 degrees Celsius. So you can see here the water which can get thermal energy from the earth, from the ground. This temperature will be 180 degrees Celsius. After passing from the turbine and the plant, the temperature will be 85 degrees Celsius. It is proposed to utilize the re-injected brine for heating the residential and commercial building in the area. And calculations showed that the geothermal heating system can save 18 million tons of natural gas per year. Now we need to determine the amount of NOx and CO2 emissions the geothermal system will save a year. You can see here if we use this, uh, you know, this water, which usually it is reinjected to the ground for the heating of this building, we can save this much of energy, which is a huge amount of energy, 18 million terms of natural gas, which this energy is equal to this much of energy come from the gas per year. So we are going to see how much NOx and CO2 emissions by using of the geothermal instead of gas will be saved per year. Take the average NOx and CO2 emission of gas furnaces to be 0.0047 kilogram per term and 6.4 kilogram per term respectively. So we can see here how much of NOx and CO2 also is produced per term in terms of kilogram per term for this gas. First of all, we need to see uh, how much NOx will be saved. So NOx, which is saved by using this geothermal system instead of the gas, is NOx emission per term times number of term per year. The NOx emission per term, which we have here, it is mentioned in the question instruction 0.0047 kilogram per term. We need to multiply this much of the NOx which is produced by using of the gas to the amount of gas which is saved per year because of using of the geothermal. So we have that 18 million terms. So 18 times 10 power 6 term is million, just the conversion of the units per year. So about 8.5 times 10 power 4 kilogram per year NOx will be saved. How we found this? If we use gas to produce this much of energy, 18 million tons of natural gas will produce this much of the NOx. So if we don't use natural gas and produce the and instead we use this geothermal system, we will save this NOx. With same procedure, we can calculate for CO2 saving, CO2 emission per term. We have that number of term per year, which is usually for the natural gas, which is usually used per year. is 18 million terms. So simply by this equation, we can calculate the amount of CO2 which is saved. You know, this CO2, it is produced if we use 18 million of natural gas per year. But we use geothermal heating system, so we will save this much of CO2. So you can see here how much NOx and CO2 is saved. To see how much this substitution of the energy resources from the uh, fossil-based fuel to the renewable resources is effective on environment. Just see this discussion. A typical car on the road generates about 8.5 kilogram of NOx and 6,000 kilogram of CO2 per year. Therefore, the environmental effect of replacing the gas heating system in this area by geothermal heating system is equivalent to taking 10,000 cars off the road for NOx and taking 20,000 cars off the road for CO2 emission. So you can see here substitution of this amount of gas by geothermal resources or geothermal source is equal to this much of car reduction in the street. Or we can say we can have this much of car in the street still if we change the energy source for the building. Why this is important? Because this substitution of energy source is much easier than the changing of this much of uh, these numbers of the cars. Nowadays we don't have electric vehicles that much enough reliable. So we have most of the car uh, are using oil and fossil-based energy resources. So they are uh, producing emission, but we don't have any option to substitute them in near future. So what we can do is to uh, have more efficient cars and also to use renewable energy in other sources, other areas as well. So by this example, we reach the end of this chapter or energy and energy systems. And what we just briefly here, I will summarize what I told you. We have started to introduce you the form of energy. We have discussed about macroscopic and microscopic energy, which were kinetic and potential energy. Discussed about energy transfer by heat, energy transfer by work, and I told you about the mechanical forms of work. I introduced you the first law of thermodynamics. Then we use this first law to see the energy balance for different system and cycle and process. And also we saw the energy change of a system. We I introduced you the mechanism of energy transfer, which were heat, work, and mass flow. I told you about energy conversion efficiencies, which also today we had some example for that. And also I told you about the effect of the energy and energy conversion on the environment, and we have seen in different examples how much it is important. I hope you have enjoyed this session, uh, and see you soon with chapter 3, which is about the substances and characteristics of pure substance.